Hello friends, welcome back to my YouTube channel. So today's video we will see the one more problem by using the moment distribution method. So this is the given beam. So as usual, so first step is to find out the fixed end moment. So now we'll calculate the fixed end moment for the span AB. So AB, for that we have the formula minus WL divided by 8. So W load is equal to 20 into span is from here to here is 4. I have substituted that divided by 8. By simplifying, it will come out as minus 10 kilonewton per meter. So now we'll see the moment about BA. For that we have the formula WL divided by 8. It is clockwise. So 20 into L is 4 divided by 8. So simplifying, it will come out as positive 10 kilonewton meter. So next we'll see the BC. For span BC, MF BC is equal to, for this is having the uniformly varying load. For that we have the formula, it is anti-clockwise BC. So WL square divided by MF CB, we have the formula, it is clockwise. So WL square divided by 20. So substitute in this formula, we will get the value. So W is 20 and W is 10. Our L is 4. L is 4 whole square divided by 30. So by simplifying, it will come out as minus 5. Here minus 5.33 kilonewton meter. So now here W is 20, L is 4 square divided by 20. Simplifying, it will come out as 8 kilonewton meter. So next we will see the CD. For CD, MF CD, for that look at here, this span has the 2-point load. For that we have the formula, that is for CB is, it is anti-clockwise, minus W minus WA B square divided by L square minus W minus AB square divided by L square. So here, so look at here, our load is 5. First we have to consider only this, only 1-point load. It means from here to here becomes A value, that is 1, and from here to here becomes B value when we consider only first point load. So now we'll see. So our load is 5, our A value is 1. A value is 1. A value is 1 and our B value is, this is B from here to here is 2. So 2 square divided by L is 3. Total span is 3. Minus W is 5. W is 5. Now see, here A becomes what? Next we will consider the second point load. We need to add this one. Now at this time our A becomes from here to here, means this becomes A and this becomes B. So A is 2. So here A is 2 into B is 1. 1 square divided by 3 square. Simplify this, it will come out as minus 3.33 kilonewton per meter. For similarly MF DC, we have the formula WA square B divided by L square plus WA square B divided by L square. Here also W is 5 and A is 1. So first we need to take the first point load, we need to add second. A is 5 and A is 1. Sorry, A is 1 meter and B is 2 meter. Substitute that. A is 1 means 1 square. 1 square. B is 2. L is 3 square. Plus W is 5. And for second point load, we need to add this. A becomes 2 and B becomes 1. A is 2. Here A is 2. 2 square, B is 1 divided by 3 square. Simplify this, it will come out as 3.33 kilonewton meter. This is how we calculate the fixed end moment. So second step is to find out the distribution factor. This is the table for the find outing the distribution factors. We only find the distribution factors only at the joint. In our beam we have only two joints, joint B and joint C. For joint B we have the member BA and BC. For joint C we have the member CB and CD. So I have written here. So for calculating the stiffness for BA, our far end is fixed. So far end is fixed, what I told. We need to use the formula I divided by L. See here, if far end is fixed or continuous, then we have to use the stiffness formula is I divided by L. We need to use this I divided by L. So I is not given, substitute, put it as it is, divided by our BA span is 4, length is 4. So substitute this, it will come out as 0.25I. So for BC there is a continuous beam is there. So for that again we need to use the, when our far end is continuous, our span is not ending here, it is also we have one span here, so that we need to use the I divided by L again when our far end is continuous beam. So I divided by L is 4, it will come out as 0.25I. So summation of K is 0.25 plus 0.25, it will come out as 0.5I. And distribution factor, we have the formula K divided by summation of K. So DF is equal to, our K is 0.25I divided by 0.5I. It will come out as 0.5. And for DF also same, it will come out as 0.5. So for now we will see the CB. For span CB it also beam is continuing. So again we need to use the I by L when we have the continuous beam. So I divided by L is equal to I. Our L is span length is 4. By simplifying it will come out as 0.25. And for CD also, for CD is fixed end. For fixed, if our far end is fixed, we need to use the formula I divided by L. So again same formula we have to use, I divided by L is equal to I divided by length is 3. By simplifying it will come out as 0.33I. Now summation added 0.25 divided by 0.25I plus 0.33I. By adding it will come out as 0.58I. So now calculate DF for CB, it will come out as 0.431. DF for CD, it will come out as 0.568. So this is how we calculate the distribution factor. So third step is to calculation of the moment distribution. So this is the table for moment distribution. So we have how many joints? 4. A, and here B, here C, and finally here D. So for here we have the member AB. For B we have the member BA as well as BC, and for C we have the member CB and CD, and here we have the DC. So now second row is the distribution factor which we have calculated just now. We need to put this value here. For AB we don't have the distribution factor value. For BA our value is 0.5. For BC also 0.5. For CB also 0.43. For CD 0.56. DC we don't have. So now put the fixed end moment value. For AB span is minus 10. For BA span is 10. For BC is minus 5.33. For CB is 8. For CD is minus 3.33. And for DC is plus 3.33. So now what we have to do is we'll do the balancing. Balancing means we have to add these two, summation of these two. Then after adding, we need to change the sign. If we get answer in positive, we need to make it into negative. If we get the answer in negative, we need to make that into positive. So now our 10 minus 5.33, it will come out as the positive, that is positive answer 4.67. 4.67, then multiply 4.67 into this distribution factor, that is 0.5. So minus, so first make it as minus, that is minus 4.67 into this 0.5. Multiply into, it will come out as balancing means minus 2.335. So again multiply that minus 4.67 into 0.5. It will come out as minus 2.335. So here also same thing. At joint C, add these two. 8 minus 3.33, it will come out as plus 4.67. Then make it into negative, that is minus 4.67. Then add minus 4 minus then multiply minus 4.67 into 0.43, distribution factor 0.43. It will come out as minus 2.0081. And here also minus 4.67 into 0.56. Multiply, it will come out as minus 2.6152. So now we'll go for the finding the carry over. Carry over means half of this. We need to do the half of this and send it to the opposite side. It means minus 2.335 divided by 2. By doing this, it will come out as 1.167. So send it to the opposite side. Here also it has no value, so here also do half of this and send it to the opposite side. So minus 2.335, it will come out as minus 1.167, and minus 2.0081, it will come out as minus 0.00405. And here also make it as and send it to opposite side. Minus 2.6152, it will come as 1.3076. So again our aim is to get the moment at joint B and C 0. We'll keep on doing this until we get the moment at this joint is 0 at B and C. So till now we are not getting, we need to do the same step here. Again we need to add these two and make it to opposite sign, then add this value to the distribution factor. Same process we have to do. So here there is no value, here only minus 0.0405 is there. So make it into plus, because we need to change the sign, no, that's why. So plus 0.00405 into multiply this into 0.5. So that will come out as, it will come out as positive, in positive value, that is 0.502. And again multiply this into here, it will also come 0.502. So same step here. Here also minus 1.167 is there. Here there is no value. So make it into opposite sign. It becomes positive 1.167. Then multiply this value into this distribution factor, that is 0.43 as well as 0.56. So 1.167 into 0.43 if you do, we'll get the value of 0.5018. And if you multiply 1.167 into 0.56, we'll get the value of 0.6535. So again in carry over, we need to off of this and send it to the opposite side. Here balancing we don't have value, so this is also, so if you do off, it will come out as 0.251. Here also same. If you do 0.52, it will come out as 0.251, and if you do off, it will come out as 0.2509. Again here, if you do off, it will come out as 0.326. 0.326. So our value is not becoming zero here. Still we need to do one more step. So our balancing is, again we need to add it. So there is no value, only 0.250 is there. So make it into negative, that is minus 0.2509, and multiply this into our distribution factor 0.5. So it will come out as minus 0.1254. Here also minus 0.1254. If we add here 0.251, it becomes minus 0.251. Then multiply this into 0.43, it will come out as minus 0.1079. So if you multiply with 0.56, it will come out as minus 0.1405. So then for carry over, we need to half it and send it to opposite side. It will become minus 0.0627, and here also it becomes minus 0.0539, and it becomes minus 0.0627. It becomes minus 0.07, minus 0.07, not minus 0.0702. So again balancing means minus 0.0539, make it as positive, that is 0.0539. Then multiply this into distribution factor 0.5, so it will come out as positive value, that is 0.02695. Here also 0.02695. And if you do this 0.0627, this is in minus, make it as positive. Then multiply this into 0.43, you will get 0.02696. And if you multiply with 0.53, you will get 0.03511. So this is the balancing. Almost now I got the value 0. So I am stopping here only. You should always end your problem at balancing only. Unless until there is nothing to balance, then only you can stop at the carry over. That problem also I have explained in my previous video. I have done one problem. you can go through that video. So these are the final moments. See here what I said, our aim is to get the moment at point at joint B and C is 0. This is almost 0 and this is also almost 0. It means our problem is correct. These are the final moments value we got. So with the help of this we will draw the bending moment diagram. So this is the bending moment diagram. I will explain here. So to find this maximum value of the point load, we have the formula, that is WL divided by 4. So substitute all the value. By simplifying, it will come out as 20 kilonewton meter, and the maximum height of this uniformly varying load, we got 10.26 kilonewton meter with the help of this formula, that is 0.064150 WL square, and this is our maximum value of the point load which is having the span which is having the 2 points load, 6.66 meter, with the help of this WAB divided by L plus WAB divided by L. With the help of this formula we got this value. And now we'll see bending moment diagram. So see here, our MAB value is minus 10.978. So minus 10.978 means it comes below this point, below the 20. It comes here 10.97, and our BA value is 8.06 and BC value is minus 8.06. Both will come at the same point. Both will overlap with each other. So it will come here 0.86 means it will plus 0.806 and minus 0.806. It will come here. Both will get overlap with each other. So our next is MCB value is 5.4. 5.4 means it comes below this point. Here it comes 5.4. And our next is MDC 2.27. So it comes here 2.27. So this portion is negative and this is positive. So if you want, you can shade it like this. So this is the final bending moment diagram of this particular problem. So I hope you all are understood. So if you like the video, like it, share it and subscribe for the more videos. Thank you for watching.